Oh, all right. Good afternoon from the West Coast. The sun came out. It was foggy the last couple days, but it's finally warmed up. It is May 7th. We're enjoying a beautiful spring. Paul, you're flopped. You got the other set of seasons. How is it down under?
Yeah, it actually is cold here on the Gold Coast today. So I actually have the heater on, which 99% of the time is AC, but today it's in heat mode, and I've got my new office warming up with the space heater in there. So
Ooh, exciting.
I'll send you a picture later.
Can't wait to see it. So welcome, everyone. This is our third installment of the Open Source Malware Show. We're going to do some quick hits on the news, and then we're going to jump in deep on talking about interpreted language malware. So let's hit first on some research, Paul, that you released earlier this week on North Korea's Lazarus Group getting creative with their kind of like Contagious Interview TaskJacker campaign. They have shifted from using VS Code files, which I was just doing some writing about earlier today. They're using a task.json file to load malware, to now it's in Git hooks. Even worse.
Yeah, well, it's actually both, right? Because it uses its initial loader is still the VS Code tasks file. They have a cursor version of it too as well, and affects anything that uses VS Code, which is Windsurf and Cursor. But so the initial loader is still in the task.json file, but it just calls these two concatenated Git commands. And there's two versions of it that I've seen so far in the wild. There's the pre-commit version of it, which we talked about in our blog post. I didn't have as much time to go into the post-checkout commit, but that's really smart because post-checkout is a Git hook that most people never call. It basically runs after you check out a new branch, or check out a branch. So what they do is they concatenate these two Git commands so that the last thing it does is it then checks out a development branch, and then boom, it runs itself. Like, it's beautiful. And just to circle back, why they're doing this is because it became really obvious for us and some of our, some of the researchers at OSM to find these URL strings in the task file. And so now these are just Git commands, which looks much more normal until you go and look at what that Git hook does. And then it calls the URL or it uses a shortener. There's several variations there. But yeah, it's smart. And it's funny too, because at SecTalks, which is a meetup I run here on the Gold Coast, it's an Australian security meetup. I know I'm running long. Somebody asked, have you ever seen anybody hide stuff in Git hooks? And I said, oh, it's been a while. It's honestly been 5 or 6 years since I've seen it in the wild. But here we go. Boom. DPRK is doing it.
Yeah. And, we saw a borrowing recently of Team PCP borrowing some of Lazarus Group's techniques for the mini Shide Loop campaign. So it's only a matter of time before this technique jumps from these, like developer interview focused attacks to, an account takeover or something like that.
Yeah, DPRK has really doubled down on this like force git commit function, which is great because then they can just keep doing these force commits again and again and again, and just changes the payload, right? Well, we saw Glassworm, which is Russian, doing that in late February or early March. So this tradecraft, coupled with the fact that AI is just able to go out there and see these things, then bring it in and then concoct these things. And by the way, the bad guys aren't going, hey, Claude, write me up an exploit for blah. They say, do this, and they describe the functions they want it to do and put a Git hook inside of a task.json file, blah, or whatever. It's a perfect storm of those two things coming together.
Yeah, whole new world. All right, let's move on to the Antrea project compromise. Are you going to sing?
Yes, I am.
The Antrea project compromise. So this is a popular Kubernetes dependency. This is a little bit of a good news story. And the good news story being, while the project was compromised, there's no malware in it yet. And so that is the good news. Good news, bad news. The bad news side is, your investigation has traced it back to the Trivy compromise. They, in all probability, got their stuff exfiltrated during the time, because we've got some evidence that they were using the poisoned version. And this kind of just goes to show threat actors don't always act immediately on the credentials that they get. Just because you don't immediately get popped doesn't mean it's not going to happen. And just assume credentials are, compromised if you're in a compromised situation. So
100%.
you've been keeping an eye on this. You've been reaching out to the maintainers. What's the update?
Yeah, the update is that the lead maintainer reached out to me and said they were not done in Trivy. I think I might politely disagree based on some evidence that I saw that I can't go into, but because it involves a vendor and I haven't gotten that checked off and blah blah. But in addition to that, there are some other kind of discrepancies where the threat actor claims in a public git commit comment, PR comment, claims to have trashed their EC2 instances. It turns out that the maintainer says that's not the case. They shut them down themselves. So listen, we're never going to get it's a he said, she said kind of thing. We're never going to get to the he said kind of thing. We're never going to get to the bottom of it. But the reality is that we've gotten pretty good now at tracking these threat actors. We like to talk about this, like, we want to see the threat actors before they make the bomb. We want to see them making the precursors to the bomb. And there's a bunch of different ways we do that at OSM and how I've been doing it as an independent researcher. But basically, that's one of the things that we do here. And we did it with the Pollen Rider user too as well. Watching the different projects that they're interacting with, and that gives us a heads up. We can then reach out to those projects, which I've been doing, and going from there. And in this case, so far, it's a good. Also, too, I do not think this is Team PCP. I think it might be somebody on the periphery. Somebody that I trust suggested that they think they might be involved in some way with Team PCP, but want to be on kind of the outside edge, because and back to your point,
it's a bit of a loose, a set of affiliations. So yeah, okay, let's move on to.
Yeah, cool. All right, keeping me the time. Good job.
Quick hits. So the next one on the list that you dropped right before we started, so I haven't researched this at all. You're going to have to teach me here. Is something called Dirty Frag, and your description here is takes copy fail and says, "Hold my beer."
Yeah, so I got a heads up from this from Jane, one of my friends, and a longtime listener. I don't put a lot of time into these things because I don't red team anymore, and so I don't build exploits anymore for red team stuff. But this just screams out red team exploit. Like, it's just so sexy. It chains together two Linux, and here's the thing: is this is a universal Linux bug. In other words, it runs on most or all distributions, because what it relies on are libraries and functions that are pre-existing in all the major distributions. And so in this case, the author tied together two vulns in a chain for just a super sexy, short, powerful local privilege escalation bug, and it's sweet. Like, I was just in the process, I was trying to get it running right. It's really easy to run, so I just was trying to spin up a VPS and blah 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 before this, but I didn't get a chance to do that. But I saw some video. They just dropped this like 2 hours ago, and unfortunately the embargo has been broken because like a third-party researcher saw like the changelog or something. I haven't gotten all these details because it's like only two hours old, but saw that and has published, and so now unfortunately the embargo has been broken. So this is out there in the wild. Bad guys are going to start taking the C code and working with it using our friends Claude and Codex. So here we go.
Buckle up. Okay, last quick hit. So cPanel is having a moment, not a great moment. So there's some actively exploited bug that's exposing, according to the internet, millions of websites. This is a little bit outside the malware wheelhouse, but what we do know is sometimes vulnerabilities lead to malware. So what do you want to say about cPanel?
Well, I mean, cPanel is used by most of the low end, CMS, WordPress, and Magento and what have you, Drupal. So one, there is a relationship between these things. So for example, bad guys have been using vulnerabilities in WordPress for years to upload malware, specifically JavaScript that then runs client side and does the bad thing, right? An overlay or whatever the case may be. But in this case, I think we're not hearing a lot about it from the InfoSec press because it's not really affecting enterprises that much. It is unfortunately in some local government that I'm aware of. But the reason why is, let's be clear, is because cPanel is typically used in those kind of lower end VPS hosting environments, and that means SMB, small shops, right? So
yeah, and I mean, I was just talking about this with Dwayne this morning on a Get Guardian webinar. The security poverty line concept. These are shops that probably are below the security poverty line, don't have the staff to investigate, secure, manage, etc. So it's kind of the worst possible scenario, right?
It is. And from an incident response perspective, we might not be hearing about it in the InfoSec press, but every incident responder I know, especially that deals with the smaller end of town, is reaching out to me saying they are hammered right now. This is a huge issue, super easy to exploit. Bad guys are all over it. And we've got bad guys in all kinds of different geolocations using this, right? You got the Southeast Asian crews, the Russians, like everybody is using this because it's just so easy and it's just so popular. So I mostly wanted to put this on the run sheet today, just to give a shout out to those, might not be hearing about this that much, but I understand it's a big deal. We understand it's a big deal, and our hearts go out to you if you're doing incident response right now.
Yeah, rough time. Okay, let's do a quick where in the world will Paul and Jen be? Because you and I possibly overcommitted ourselves slightly in the month of May. It's going to be awesome. So I'll start next week. I'll be in the Bay Area twice this month. I'm going to head down next week for a cool event called the San Francisco Secure Software and AppSec Summit. And that'll be over in Palo Alto. I think it's on the 14th. Yeah, that's next week. What am I going to be talking about? I'm going to be talking about, this is like going to be 100% full of hot takes. How should AppSec actually run? I'll be on a panel with some very recognizable names and lots of audience opinions here. So I'm looking forward to hearing what people think. At the end of the day, I'm just going to say, it really depends on your organization. I don't think anybody can tell you how AppSec should run, but there's probably a lot of things that we can tell you not to do. And then the other event that I'm going to be doing in May will be toward the end of the month. Zenity is doing their second AI Agent Security Summit. I didn't make it last year. I heard it was super cool. So I'm excited to have been invited to speak at this year's event, and I'm going to be talking about malicious AI skills. So yeah, if you're coming to either of those, come say hi. Paul, you've got 4 things.
Oh yeah. First, I want to circle back to your first one there. That's the Clutch event, the first one, right?
Yes.
Yeah. So my friend Cole Cornford and Ben Gittins will both be there. CK Tricky, Ken Johnson will be there.
I know. All our buddies are going to be there. It's too bad you aren't coming.
I know. I don't know if it's worth a trip over from. I'm doing a lot of trips this year, so I'm glad to keep up. But that one sounds like a great one. I've done a number of the Clutch events here in Australia. They do a bunch of them here, and I'm actually doing one in Sydney with them. I'll be on a panel in June with Cole and the team. But yeah. So for me, I well and truly overcommitted. So I'm going to Melbourne next week for Melbourne B-Sides, which is, I know I run the Gold Coast B-Sides and, that's my local, but Melbourne B-Sides, frankly, is probably my favorite B-Sides in the world, just because so many of my friends there. I spent a lot of time between 2018 and 2022 going to Melbourne almost every week, and just have a lot of friends there. I have a lot of connections to the InfoSec community and AppSec. There's a really strong kind of AppSec scene there too as well. But all right, so Thursday night, I'm speaking at the the AppSec meetup, which is really well attended in Melbourne. Like last time I went there, I spoke there was 100 people. It's huge thing. And anyhow, it's dope. That's Thursday night. Then Friday, I'm giving an all-day training at Melbourne B-Sides. The conference starts on Saturday, but they do the day before training. So I'm going to be doing some of my some of my kind of traditional CTI stuff. Anyhow, and then I'm keynoting on Saturday, and then I'm on a panel with Ricky Burke on Sunday, and then I come back to the Gold Coast, and then I forget, is it Wednesday or Thursday? But Wednesday or Thursday, I'm speaking at OzCert, which is like one of our longest InfoSec conferences here in Australia. It happens to be on the Gold Coast. It's in my local hometown locale. And then and then Saturday is Gold Coast.
There's more.
But wait, so and that's when I have my heart attack. So I will be looking forward to from the 24th going forward, when I have a lot less to worry about and be anxious about.
Right on. Okay. I teased it last week. We have time for it this week because thank goodness nothing blew up. I want to talk about interpreted language malware versus compiled language malware. You and I have kind of been fiddling around with a white paper on this for a little while. We haven't gotten it over the line because
it's giant.
Yeah, I might have written too much.
This is fucking War and Peace right up here, but it's legit.
It really is. It's if I were going after like a doctorate or something, yeah, maybe this.
It's pretty technical, like so. And that's why I think it's taken us.
It needs to be right, but like, let's just talk about why we're focused on interpreted language malware, and that's because in malicious open source, most of the time, malware is written in JavaScript and Python, and that differs from the malware that you more traditionally see through, phishing attacks and things like that. And there's several reasons that interpreted languages are chosen. They have specific properties that makes it harder to detect. So, we talked about all kinds of other things earlier that make the malware hard to detect. And that's all sort of outside of, the interpreted language nature itself. And so one is that there's no compilation step. The source code is shipping as the attack artifact. So it's not going to be discarding variable names, comments, structural intent, that kind of thing. This is at the semantic level. Import time and dependency context execution is, a real bypass. Why don't you talk a bit about that, Paul? We've been kind of discussing the role of post and pre-install scripts, which can get, discovered by a sandbox. But what we know about, a lot of the open source malware that we're seeing is a lot of them have pre-install and post-install scripts. We talked about it last week on the show. What are they doing differently in interpreted language that lets those scripts sneak through in a sandbox?
Yeah, I mean, it really boils down to one simple thing, right? Which is that the install scripts allow it to auto execute. That's what it comes down to. It auto executes. So just the process of you downloading it and installing it runs the payload. It's like if you were to download the latest malicious binary, and then when it downloads, it automatically also runs. It's effectively the equivalent of that. And I think, as you point out in the white paper and some of the other stuff we've written about it, is that those scripts are there for a reason. JavaScript in particular, which makes heavy use of these things, is used in all kinds of different ways. It's used to do. I build a bunch of my CLI tools in it, and having these install scripts, these lifecycle scripts in a CLI is really helpful because it does the thing to make the CLI be able to work. JavaScript package.json also has the ability to create a bin, which creates a link and an alias. But I think that the post-install scripts are there for a reason. It makes it really easy for bad guys to run their payloads. The Axios, compromise was when it called the crypto plain JS file. I had a post-install script, and bada boom, bada bing, it was running on lots and lots of pieces. So there's that, and then, but the problem is that we talk a lot about post and pre-install scripts, and those are a huge part of the JavaScript kind of ecosystem. We have similar things in Python too as well, with the init and the way setup runs and a bunch of other things, but it's particularly an issue in JavaScript. But I want to say, like, not all malware, JavaScript malware, uses these lifecycle scripts, right? Many of the good things, when I say good, I mean the effective bad ones, right?
Smart ones, yeah.
Yeah, work on import. And you and I have talked a lot about this, right? And it's not just JavaScript. I saw that Socket found 6 or 7 NuGet packages that all were doing what they said on the tin. We're doing, so people would download, they would install them, and they would run. Well, first they would look at them, they would see, oh yeah, look, it's doing what it says it's supposed to. So then they use them, and away they go. Now that's in a different ecosystem, but the point remains that if you can actually do the good thing, then people won't vet it well enough to see if it's doing a bad thing as well. So the combination of those two things just makes JavaScript particularly painful. But it's moving out. Bad guys are taking those patterns from JavaScript and moving out to different languages. So
yeah, we've talked about sandbox evasion quite a bit, you and I. In addition to it firing on install or on import, they can call out to the OS APIs to detect if they're in a sandbox environment. You've documented some beavertail variants that are pretty sophisticated with their concealment, environment gating checks, things like that.
Yeah, I mean, traditional malware also does that, but I think the difference is that we have the fact you have to set up an interpretive environment in the sandbox, and then if it's on import, you have to call it in the right way. You have to ask it in the right way to do the bad thing, right? And that happens when you import it into, like, if it's a crypto library, when you import it and it goes to do the thing, it knows how to hand the parameters over to it. But that doesn't happen in the sandbox. The sandbox doesn't have any context around how you actually get this on import thing to blow up, to go boom. And there's all kinds of other things like that. It's just the fact that, like, setting up the environment is such a pain in the ass, right? Which is the reason the bad guys get saddled with this too as well. But even now, before the bad guys run, before DPRK drops Beavertail or Otter Cookie, there typically is at least 2 bash scripts just to set up the environment, the interpreted environment, right? So just to get that set up correctly and have it run is painful. And so, that's something else that the sandboxes often miss.
Yeah. And, I think it's worth taking each requirement for a sandbox to be effective and talking about that, because we do get asked on a fairly regular basis, oh, you're sandboxing, you're doing dynamic analysis, you're detonating. We do believe that those techniques have a place, but with interpreted language malware, by and large, they're not as effective. And so, in terms of the requirements, the artifact's got to be able to execute. The sandbox has to be able to run the file type. Well, NPM or PyPy requiring a full Node.js or Python runtime setup, there's going to be some issues there. It's got to fire during the window that it's in the sandbox. Those default durations could be, a minute up to, 300 seconds. And often, because things are time gated or environment gated or whatever, it just won't fire, right?
And most of those open source, the JavaScript and Python that we see, you mentioned this earlier, but has a delay now. Like they specifically delay it because most of the sandbox, like if you use AnyRun or Triage or any of those, you typically run those sandboxes for 1 minute to 5 minutes max, and then they just wait longer than that, and it never goes boom. I think, for everybody, we get into these, I have these kind of technical conversations with our friends, right? And won't say any names here, who really like to sandbox, and that's cool. But there's always a trade-off there, right? There's time, there's compute. Now, when it makes sense to perhaps sandbox is when you have a very, very heavily obfuscated file, which we're seeing a lot, with DPRK and other stuff in JavaScript and in Python. A lot of people are using PyArmor in Python. PyArmor, you need to fix your shit. Anyhow, so if you've got a heavily obfuscated file, like the time that it takes might take as long as what it takes to actually sandbox it and get good data out of it, right? But setting up and instrumenting that sandbox is so much more complicated than if you have a good static analysis tool, and that's why I've really focused on static analysis for these things.
Oh, you read my mind. I wanted to wrap up with us talking a little bit about static analysis and where AI fits in. Again, I was on a a webinar this morning where we were talking a bit about, where AI can hurt, where AI can help. Certainly, as we've talked about several times, the threat actors are using AI to their benefit to be able to move faster. So, without spilling the trade secrets, what's your philosophy here? Because obviously, I know you don't believe you can just set AI loose 100% and it'll detect malware. There's a balance there.
Yeah, I mean, there's people that are heavily using LLMs in their malware analysis pipelines and creating a lot of false positives, right? We see that, and you can quantify that. I think that and there is this expectation you can just run an LLM and it figures it out, right? But the reality is that like I just had a sandbox blow up last week because it was this heavily kind of looping obfuscation. It just used up the memory and OOM'd my sandbox. Where was I going with that? That part,
rabbit hole.
That
when to use AI.
Thank you. When to use AI. Listen, AI is really important to have inside of your pipeline, but we really, we found that custom purpose-built static analysis is the best, fastest way to do this. And that doesn't mean these other things don't have a component. I think it is important too, when you're doing your static analysis, to be coming at this from a really thoughtful perspective about how things go boom. And me and a good friend had lunch, a couple of weeks ago, and we were talking about, when you're doing pen testing and bug bounty, you have like the sinks and sources. I've taken a concept of that and moved with it and built some libraries and some functionality around that to understand specifically how the malicious execution order happens inside of these things. And that's because I built the static analysis myself. I built, oh man, we can get into the fuzzer, but we'll leave that for another time. Anyhow, that's my take. I custom, purpose-built, focused subject matter expertise inside of the static analysis engine is probably the best way to go.
All right. I think that leaves us at time. As always, reach out if there's something you want to hear about, but otherwise, join us next week to hear the news. And I don't know. What are we going to talk about next week? We haven't decided what our deep dive is going to be yet. Do you have some ideas, Paul?
I've got some ideas. We might have to talk about kill chain, but we'll definitely come up with something sexy. That'll be before my training, so I'll have to be Johnny on the spot. I'll keep my answers even more terse.
Thank you, and I'll see you.
See you, everybody.